Hello everyone, welcome to my YouTube channel. Today we are going to prove theorem number 1 of grade 10, which says prove the diagonal of a parallelogram bisected. So for that, let me draw a parallelogram first. So here ABCD is a parallelogram and let me draw its diagonal from A to C. So the line drawn from A to C is called a diagonal. Also, the line drawn from B to D. This is second diagonal. So a parallelogram consists of two diagonals. This one diagonal and this one as well. Diagonal. So now we know about diagonals. So now what is bisect? For that, let me draw another parallelogram here. Yeah. So this is a parallelogram ABCD, and as our question says diagonal of parallelogram, so we are going to draw only one diagonal from A to C. You can draw from B to D as well, as that is also a diagonal. So from A to C we drew a diagonal, and if we cover this part of this parallelogram, we see half part of the parallelogram. Similarly, if we cover this part of the parallelogram, we see half part of this parallelogram. So what is bisect is? Bisect means if a diagonal bisects a parallelogram, it means it divides the parallelogram into two equal halves. So the two equal halves of this parallelogram are ACD and ABC. So in our parallelogram, if so in our theorem, if we prove triangle ABC is equal to triangle ADC, then we can prove that the diagonal of a parallelogram bisects it. As triangle ADC is equal to triangle ABC means both are half of the parallelogram, so it bisects. So AC bisects the parallelogram. So let's get into the process of proving. First of First of all, we have to draw a parallelogram here. Both sides equal. And let me name it A, B, C, D. And let me draw a diagonal from A to C. As I said previously, you can also draw a diagonal from B to D, not a problem. And first, we have to write given. So given in this question is A, B, C, D is a parallelogram and AC. This AC is a diagonal. Now we have to prove triangle ABC is equal to triangle ADC, or triangle ADC is equal to triangle ABC. So let me write triangle ADC is equal to triangle ABC. So let me draw a table first. So this is a table. Right one side is statements, and then reasons. Number 1, in triangle ADC and triangle ABC, this AD is equal to BC because they are the opposite sides of a parallelogram. So AD is equal to BC. Reason: opposite sides of a parallelogram. Now number 2, we have DC is equal to AB. The same reason, opposite sides of a parallelogram. Now we move to the third reason, third statement, that is AC is equal to AC. AC is equal to AC, that is common side. So this side is equal to this side is equal to this side, and this side is equal to this side. So these two triangles are equal to each other by side axiom. So in number 2, we are going to write triangle ADC is congruent. They are congruent to each other by side axiom. Is congruent to triangle ABC by side axiom. And then comes triangle ADC is equal to triangle ABC congruent triangles are equal in area. So we proved that triangle ADC is equal to triangle ABC, which means this part and this part are equal. So this part are equal means this diagonal can bisect these two parts of a parallelogram. It bisects means it can divide this parallelogram into two equal halves. Two equal half means triangle ADC is one half, triangle ABC is another half. So these two are equal means diagonal of a parallelogram bisected. So at last we have to write here proved.